assignment-wise, we're going to go on page 196. Write this down quickly. I'll go ahead and write this down real quick. Page 196 is what I'm going to assign for you for Thursday. I want you to do 1 through 35 odd. And we're going to look at due Thursday for this, all right? All right, so take a second and get that down there, if you would.
Trimester 1.
Do I need more time with that right now? You guys got her now?
Sure.
Okay. Did I get notes up there, everybody? Did you guys get notes already?
No.
Yeah.
Yes? No?
I'm
Yes?
joking.
Oh, okay. All right. All right, here we go. Everybody's got that down?
Yeah.
All right. Guys, section 4.5 is going to be kind of a little bit of a jump compared to what we've been doing here. We got to understand some things about exponents today. Try and tie together everything that we've worked on involving greatest common factor and least common multiple. So today we're going to start looking at rules of exponents in section 4.5. And our goal today is to be able to multiply and divide powers. All right. Show of hands. You guys have, you know what an exponent is, right? What's your best definition of an exponent? If I say, what do you think an exponent is, or how would you explain an exponent in mathematical terms? What would you say it is? How would you describe in your own words what an exponent is? Billy, you got an idea? Anybody got an idea?
A number.
Well, it is a number. It can be a number. Okay. Seth, what do you think?
Isn't it the number times the number?
Yeah, it's a number times itself, right?
How
So,
many times?
It's like squared and
Cubed.
okay.
4 powers.
So if I say something like this, just to make sure we're on the same page, if I say 4 to the third power, what's this really implying right here?
4 times 4 times
4 times itself, how many times?
4. 3 times
Okay, what's the exponent in this expression right here, the 4 or the 3?
3.
The 3 is the exponent, right? Anybody remember what we called the 4?
Main.
The what again?
The main.
Not quite.
The main force.
Is it a hyphenated
The
word?
base. I mean the base.
Base? Very good. Base, all right. So yeah, this simply means 4 times 4 times 4. Multiply that base of 4 3 times, okay? So how many would say, yeah, I know that. We've seen this before, right? Okay. Well, today what we're going to start looking at, we're talking about multiplying and dividing powers. And the first thing I've got up here is product of powers property. Okay, right down here, big rule. Very important rule. You might want to highlight this rule. It says to multiply powers with the same base, what are you doing with their exponents? What's it say?
Exponent.
Yep. It says to multiply powers with the same base, you want to add the exponents. Now let me explain to you why you would do that.
Put an asterisk next to it.
Is a star okay, Mr. Slater?
Yes. Nice, pretty Christmas star.
It is pretty.
My mom has that exact same type of star.
That's pretty important stuff. It says to multiply powers with the same base, add their exponents. So here's an example. If I would start with something like this, suppose I would start out 3 to the second times 3 to the 5th power. According to that rule right up there, first of all, it says to multiply powers with the same what?
Base.
Same base. Do I have the same bases in the two expressions that I'm multiplying?
Yeah.
What is the base of each expression?
3.
3 is the base. What does it say to do with their exponents? says to
Add by 2.
add them together, right? What are the exponents of my bases of 3? What are the exponents of these bases of 3? 5 and 2. So according to the rule, it says this would equal 3 to the 7th power. Okay. Now, why is that true? Anybody know why that's true? Don't times the base. Okay. Well, let's just kind of talk about why we would add the exponents here. If the bases are the same, why am I adding the exponents? Here's the dealio. Would you guys agree right here, this part, I'm going to underline in blue. You guys agree this part right here, 3 to the 2nd power really represents 3 times what? 3. Okay. How many 3's are being repeatedly multiplied here? 2 of them. Okay. And then, if I take a look at the 3 to the 5th, I'll put that in red. If I'm taking 2 3's here and multiplying them to how many 3's here?
5.
All I've done is taken each expression, or each exponent, if you will, or each power, or whatever you want to call it, and written them as repeated multiplication. The first expression had 2 3's, the second expression had 5 3's. So when I put all this together, when I underline all these, how many 3's did we have? How many 3's did we have? There were 7 of them, right? 7 of them. So that became 3 to what power then? Came 3 to the 7th, right? Everybody agree? Alright, next one's going to be more difficult because what I'm going to start doing is saying, you know what, there are common bases, but there's also going to be some coefficients that lie in this situation too. Okay? I'm going to write it like this. Example number 2, right down here. I'm going to write it as 2x to the 5th times maybe, I don't know, 3x to the 3rd. Okay, this is kind of tricky right here because all of a sudden, instead of just having a number and a power right up here, I'm involving some variables, right? Okay, let me ask this question first. What are my exponents in this situation? What are the exponential values in this? What are the exponential values? 5 and 3. Now this is simply saying right here, the only thing you're taking to the 5th power is the what?
X.
Am I taking the 2 to that power? Absolutely not. This is saying the only thing I'm taking to the 3rd power is just an x. Alright? When you have stuff written like this, your best situation is to do something like this. Rewrite this. Alright, I'm going to change the order. I'm going to put the coefficients, or these constants, out front. I'm going to call this 2 times 3 times, alright, right here, gang. This part of x to the 3rd right here, that 3x to the 3rd right here, how many x's is that? How many x's is that?
3.
3 of them. So how many x's could I put in the back here now? 3 of them? Okay, and then likewise right here. How many x's are right here? How many x's do I have right there?
5.
Thank you, Mr. Slater.
Somebody had to do it.
Okay, so all I've done is kind of taken the order out, but what are the common bases or the common parts that are going to get multiplied together? Well, all the x's are the same, aren't they? What do you think you're going to do with the 2 and 3 right out front here? What's it say to do? 2 times what? Multiply, right? What is 2 times 3 going to get you?
6.
Okay. How many x's do I have?
5 plus 3.
8 of them, right? Call it 6x to the 8th power. So take a look at this right here. I didn't really have to write all that out. Could you guys recognize that the 2 and the 3 that are not exponents would form this 6 right here in front? And then look at your x's, x to the 5th and x to the 3rd. What's the 5 plus the 3 get for the exponents that you add up? 8. So you see that real quickly? Okay, so here's what I want you to do. I want you to look at the example that I did in example 1 and example 2. kind of understand what we're doing. Right? Let's see if we can't talk our way quickly through example 2, and then we'll try some on our own. All right? So how about a show of hands on the first one? 4 to the 7th times 4 to the 11th. How do I rewrite that as a power? What do you think, Brandon?
You just add the 7 to the 11.
Add 7 and 11. Right? So how am I going to express this again? I didn't catch it.
4 to the 18.
Good, very good. 4 to the 18. Okay, yep. Like bases are 4, so just add the exponents. Okay. Isn't number 2 much like number 2 up here?
Yeah.
Let's see. 2 and 7 are not exponents, are they? So what am I going to do with the 2 and the 7? Not add them. What did we do with the 2 and the 3 here to get my... Okay, you times the coefficients, all right? Times the coefficients. So what's that 2 and 7 going to get us, kiddos? 14. And now, the parts that have the exponent are the x's. X to the 2nd, x to the 6th would become x to the 8. Okay, so 14x to the 14x to the 8. What do you guys think?
It's easy.
Pretty easy, right? Okay, so let me throw some problems up here for you guys to try. Make sure we're okay with this first part. And then we'll start looking at some ideas that involve division. Okay. Let's see, kiddos, you try these. Ooh. You want me to make this difficult or easy?
Difficult.
Let's go 2 to the 5th times 2 to the 12th. Down here we go x to the 6th times x to the 13th. Over here we'll go, ooh, I like this one. So I'm going to star this one. 5 to the 6th times 5. And let's go 3x to the 7th times 7x to the 20th. Okay. That top right one, be very careful on, okay? And if you're not sure on the top right one, there's a little side note I'm going to end up making here with that one. But give those 4 a shot. Take a minute, give those a shot. Check with someone around you, see if you agree. Make sure you get them written down for sure. Okay, who's got the first one? My basis being 2. Anna, you got the first one? 2 to the 17th or 4 to the 7th? Okay, got to be really careful on this right here. How many 2's are really here? Okay, don't confuse yourself on this right here. Down here I'm going to multiply the 3 and the 7 because they're in front of a variable like this, all right? But this is like this example right here. Did the 4 change at all? This is like you've got saying 7 4's total and then 11 4's total. So how many total 4's do you have is what this is really saying. Well, you got 18 of them, right? Down here this is saying you've got 5 2's and 12 2's. So how many total 2's do you have? Well, but if there's 5 and 12 of them together, if there were 5 2's over here and 12 2's over here, how many total do you have together there? There would be 17 of them, right? So instead of 4 to the 17th, what would you choose to call this? 2. Say it confidently for me now. There you go, kiddo. Very good. All right. let's go on this bottom left one. Bottom left one. What have we got there? The only thing that's different here, instead of having a numerical base, you have a variable base, right? What'd you guys come up? I heard it, Brandon.
X to the 19.
How many agree x to the 19? Okay, good. Okay. Next one's kind of tricky. Trying to throw a curveball by. Did anybody come up with a solution here? Chelsea, what do you think, kiddo? Just 5. Okay, there's a thought. Different thought?
Yes. 5 to the 7.
Here, 5 to the 7. Bill? 5 to the 6. Sounds like I've got some explaining to do, right? Sounds like I've got some explaining to do. So, okay, let's check this out.
You say that to your daughter ever? Lucy, you've got some explaining to do.
Lucy, yes, because she's my little Lucy. I call her. She's my little Lucifer. Is what she really is. Okay, here's the deal. Let's go back to this idea of repeated multiplication up here. Okay, this part right here, this 5 to the 6th. This would really be how many 5s? There would be 6 of them total, right? So isn't this part really going to be 5 times 5 times 5? 3 1. Do I have all 6 5s listed right there? So I'm good there, right? Okay. I also need to account for this 5, but how many 5s are really right here? There's just 1. Okay. So when there's no exponent by a number or a variable, you always assume what number is out there. Assume that this is really the same as 5 to the 1st, because we got to account for that 5. So how many 5s do I really have here, gang? 7 of them, right? So I should call this 5 to what power? 5 to the 7th. So real quickly, let me try and help you with this. Suppose I had like x to the 3rd times x. Well, let's see. The x's are the like base. The first x value has 3 x's, doesn't it? Second one is just an x all by itself. But how many totally? 4. So that would be x to the 4th, right? Okay. Make sense, everybody?
Yes.
Good? All right, how about the last one right here? This is a bit different. What do you got to do with the 3 and the 7 here first?
You got times it.
What is that?
21. 20.
And then x to the?
27.
Very good. 21x to the 27. Okay. How you guys feel about this?
Good.
Pretty good? All right. Everybody got everything down?
Yeah.
Okay, all good? Okay, let's run on to page 2 here quickly. Guys, the rule is this: like basis. What do you do with the exponents when you're multiplying? What have we been doing with the exponents? I multiply like basis. What's the rule up there that we put a big gold star by? Add the exponents. Good. All right, so take a look at the second page here quickly. All of a sudden, instead of multiplying powers, we're going to start dividing. Now, guys, if multiplying like basis meant add exponents, what do you think it's going to mean when we divide like basis? What do you think we're going to do? Got a guess?
You're gonna subtract.
Going to subtract. And that's what the rule's going to say right here, kiddos. Yeah, right here. It says to divide powers with the same base, you're going to subtract the exponent of the denominator from the exponent in the numerator. Basically, top exponent minus bottom exponent. So check it out. If I want to say something like this, suppose I've got 9 to the 5th power divided by 9 to the 2nd power. This kind of goes back to the idea of using common factors to put fractions in simplest form. How many 9s do you really have up top, gang? How many 9s are up here?
5.
So I can write this as repeated multiplication as 9 times 9 times 9 times 9 times 9. On the bottom, where are you at? 9 times 9. Now, if we look what's common and start canceling, guys, how many sets or how many pairs of 9s would cancel from numerator to denominator? How many sets could I take out?
Say it louder.
How many?
2.
2. Yep. Okay, so once I've canceled the sets that I can cancel that's in common with the numerator and the denominator, what's left up top?
9 to the third.
9 to the third. Okay, so let's just kind of prove this rule. Up top we had how many 9s? And on the bottom we had 2. The bases were like bases in 9, so what did we do with the 5 and 2 to form a final answer of 9 to the third?
You add, subtract it.
We subtract, okay? So maybe a little rule we can come up. Multiplying is to addition of exponents as division is to
Prove
subtracting exponents, okay? If I had something like this, oh, I don't know, x to the 9th over x. What do you guys think there? What do you guys think there?
It'll just be
Don't forget what we said about this x. This x without an exponent is really x to what power?
1.
So this is going to be x to the 9th over really x to the 1st. So since it's division, do I add the 9 and 1 or do I take 9 minus 1?
Minus 1.
So what's that going to simplify to here, Mason?
Over 8.
X, not over it.
8.
X to the
8.
8th power. Very good.
I put
X to the 8th. All good? All right, so let's look at some examples that are kind of like the multiplication ones. What happens if I do something like this? What happens if I have something like, oh, I don't know. What happens if I have like 16? I'm going to write it. Maybe this will help you see it a little bit better. X to the 7th over maybe something like this. Maybe 8. And then x to the 3rd, maybe. I don't know. Okay. What are my like bases, first of all, guys? What base is exactly alike up there? The x is exactly alike. Now, what's different here? What's the curveball I'm trying to throw by you?
The 16 and the 8.
16 and the 8 are my coefficients right here. And the last problem's on the first page. We took those coefficients and we multiplied them together, right?
Yep.
Yeah.
The coefficients of 16 and 8 are one above the other. What do you think we're going to try and do with
You're
that?
gonna divide.
Divide them, or at least simplify them in fraction form if I can. So here's the dealio. Work with the 16 and the 8 first. We almost split this like this. Okay? Could you do 16 divided by 8?
Yes.
What is that value? 2. We see the 2 part? Okay, now the x to the 7th and the x to the 3rd,
X.
same situation where you've got like bases. So am I adding the 7 and 3, or are we looking for a difference between the two?
Subtract.
So what is 7 minus 3?
4.
So I'm going to call this 2x to the 4. All right. I want to try one where this coefficient doesn't go evenly into this. Okay? So what if I have something like this? What if I have something like 20 x to the 9th over 6x to the 3rd? Okay, I think that anytime you have fractions like this, split this stuff. Okay? I like splitting them like that because I think that it keeps the coefficients to the left for us to work with that, and then it forces us to look at our common bases on the right and then apply the rules that way. Okay? First question, guys, looking at the coefficients of 20 and 6. Will 6 divide evenly into 20?
No.
Here's the second question then. Can 20 and 6 be simplified? In other words, is there a factor other than 1 that divides into 20 and 6?
Yes.
What value is that, Seth? Alright. Seth is saying, you know what, 2 will go into both of these, so we could simplify this. How many times would 2 go into 20? Okay, so I'm going to divide this by 2 over 2. What is 20 divided by 2 up top again? Well, you said 10, right? What's the 6 divided by 2 going to get you in the bottom? 10 over 3, right? Okay, now this is where things get kind of confusing, but I think if you just follow the rule and listen to me, you'll be in good shape. How many x's are really up top here, guys? 9 of them. How many x's are on the bottom?
3.
This is a deal where I would take 9 minus 3 and have x to the 6th left over. Okay, now my question is this. If I take that 9 minus 3 right there and there's 6 x's left over, do I put those x's up top with the 10? Or do I put them on the bottom with the 3?
Up top.
What's your explanation for up top, Seth?
Because that's where more of the X's are.
Most of them were up top to begin with, right? So if we eliminate some stuff, I can't eliminate everything from the top, but I can eliminate everything from the bottom, right? So what I'm going to tell you is this.
Put it in.
I'm going to put the x to the 6th up top. Do you guys understand why it's a 6 up here? First of all, that was the 9 minus 3 part. Yeah, put it up top because there's going to be more up top than there will be in the bottom in this case. Now if this was switched around, there was 3 up here and there were 9 here, where would the x to the 6th have gone then? If there were more x's on the bottom than there were on the top, where would the
On
x?
the bottom.
Okay, that's not going to happen in this section. That's going to be something we explore next section in terms of how do we deal with that. But let's have you try a couple here, see what you can do with these. Any questions about the division? Really, it's the exact same, just the rules are opposite, aren't they? Okay, pretty simple stuff today. Any questions to this point? Slater, Miller, anything I'm missing? All right, let's see what you guys come up with for this. This next one, I'll kind of zoom up here a bit. All right, let's see what I can get here. I'm going to kind of put on your own. I want you to do the following. 5 to the 9th divided by 5 to the 2nd. Let's go, ooh, I like this one. 4x to the 13th divided by 24x to the 9th. 12 to the 7th over 12 to the 4th. And finally, ooh, I like this one too. 14x to the 16th over 6x to the 11th. I'll get out of your way here in a second. Okay, there they are right there. So see if you can simplify them. Guys, the bottom two, I think it'd be a good idea to put your split line in there between the coefficients and the bases. All right? You want to put that split line in there between the coefficients and the bases for the bottom two. All right? So take a minute and see what you come up with, kiddos. Yes, sir. Why? Which one are you looking at? Bottom left one? 4x to the 13th, I'm sorry. Let me read the rest.
All of a sudden, when I come here to high school, I get a B plus.
Too easy, huh? No.
You actually extend stuff. That's how it works.
That's a 9 up there. I'm sorry. Let me zoom back up. I think we're. I'm sorry about that. I went too quickly, didn't I? Here, I'll zoom back up here quickly so you guys can get them down again. I'm sorry about that. Give you about 30 more seconds here on this one.
Wait, which one are we on? Five?
All right, so our first one right here, guys, 5 to the 9th over 5 to the 2nd. This should be very quick and very easy. What did you guys come up with? Somebody shout it out.
5 to the 10th.
5 to the 7th. Yep, just 9 minus 2. The bases are 5. So this is really 5 to the 7th. How many had 5 to the 7th there? Good. Okay, my next one, bases are 12, so 7 minus 4. What do we got?
Which one?
So this top right one. 12 to the what? Third, right?
And then you got 6x to the 4th.
Okay, we got to be really careful on this next one. Okay, I'm going to split this right here as best I can. Okay. Let's look at the 24 over 4 part. I meant 4 over 24 part. Look at the 4 over 24 part. Coefficients for both the numerator and denominator. Can 4 over 24 be reduced?
Yeah.
To what? What's the largest factor that would divide evenly into 4 and into 24? Won't 4 go into both of them?
4. Yeah.
4 goes in how many times up here, guys?
1.
1 time. How many times will 4 go in this?
6.
So I've got 1/6 as my simplified fraction of the coefficients. How about the 13 minus 9 part for my bases then? X to the 13th and x to the 9th. How do I write that as a new power of x?
6x to the 4th.
Okay, is that x to the 4th going up top or in the bottom?
Top.
Top, because 13 wins out over what? Is it 13 more than 9? Okay, so I'm going to leave that up top. So my solution here, 1x to the 4th over what? 6. Now if you check any answers anywhere, this next assignment, they're going to write this as just x to the 4th over 6. Isn't 1 times x to the 4th just going to be x to the 4th right there? All agree?
Yeah.
All right. Let's talk our way through the next one here.
I got it.
Will 6 divide evenly into
No.
14?
No.
However, can 14 over 6 be reduced?
Yeah.
What over what?
2 over 2.
Careful. Okay, so you're using 2 to go into both. So what would that become then, Mason?
7
7
and 12.
and what?
12.
Go the other direction, please. Divide.
3.
7 and 3. Okay? Now, look at your like bases of x. The 16 minus 11.
7 x to the 5th.
So you want to leave x to the 5th where, Brandon?
On top.
So you have 7x to the 5th all divided by 3.
Where's your foot putting that?
Oh, I'll get you there. Okay? You guys have those down? Do you guys see the difference here? I just want to show something here. Guys, the 5 is what had the exponent. The base was 5, the exponent was 9. When I do the operations with the exponents, does my base ever change? Does the base ever change? No. Did my base of x ever change over here? No, but can coefficients change? The answer to that is what?
Yeah.
Yes. Okay. Don't change bases, but coefficients can change. Then
I'll
you're
write
either
that
adding
down.
exponents or subtracting exponents. All right. Questions to this point?
Don't change.
All right. Let's look at the last page here quickly then.
Wait, what?
Don't change bases, but you can change the coefficient.
Don't change bases, but you can change the coefficient. You want me to jot that down?
Yeah.
Yep. Please.
Maybe a rule to think about. You can change coefficients.
And you know, I know you guys forget sometimes, so you could put like 6 x to the 3rd, and you can put a line over to the 6 as the coefficient, and a line over to the x as the base.
Cannot change the base. The base stays the same.
Fly. What's it one more thing?
Okay. But the exponents can also change, right? So we're getting different exponents in the end.
Yes.
So you might want to write down. Yeah, that's just the rule. That's all the rule. You can remember that. Okay. So take a second, get that down. We'll look at this third page here. Kratzky, you wrestling tonight?
Yeah.
Got an opponent already?
What?
Got an opponent?
No.
Wanna wrestle me?
Yeah.
My name's the square root of pain.
Alright.
My finishing move's the opposite reciprocal.
Alright. That was pretty good.
You like that?
Yeah, that's pretty good.
John, did you get that down, buddy?
Yeah.
All right, let's roll. Last page here quickly.
Hey, you know need English to do math.
Yeah, you do. Okay. All right.
You know what exponent means.
Although I did tell the English teacher yesterday that
Yeah.
P and W are the only letters that are functions in the alphabet. So, all right. Let's go ahead and look at some examples that are involved properties. Okay. This is where things get kind of tricky. So something like this, maybe 4x to the third times maybe 2x to the fifth over. Let's just go x to the second. See what we can get here. All right. Now up top we're multiplying, then we're doing some division. So we're kind of combining multiplication and division together here, aren't we? Okay, so up top, I might just circle the bases up here. The bases up top are x, aren't they? And then down here I've got a base here. So are 4 and 2 considered bases or coefficients in the top? Are the 4 and the 2 considered bases or coefficients in the top? They're considered I'm sorry, I meant exponent or coefficient. They'd be a coefficient, wouldn't they?
Sure.
Okay. So right up top here, couldn't I rewrite this top? What's the 4 times 2 going to get you, gang? 8. And then help me add the exponents up top. What's 3 and 5 going to add up to? 8x to the 8th. Good?
Yeah.
On the bottom, you just have x to the second, don't we? Okay? Now guys, if I split right here, there's really nothing over here, which was really the same as division of 1, isn't it? Okay, so what's the 8 divided by 1 going to get you, Brandon? 8.
Then you get x to the sixth.
X to the 6th. Do I need to put anything in the bottom then?
No.
No. Okay, so 8x to the 6th is what you have there. Okay. Let's try another one. Let's go something like this. 4m to the third times m to the fourth. And now I want to look at dividing this by, say, 12m to the second. All right, so help me out here real quickly. Up top, how could I rewrite the numerator, I guess is what I should say. 4m to the 7th, okay? 4m to the 7th. So I've got 4m to the 7th. Okay, and on the bottom, still 12m to the second. And now I might choose to split my coefficients from the bases. How about 4 over 12? Can I reduce that? 1 over 3. Okay? So I'm going to have the 1 over 3 part as my simplified fraction of coefficients. And then how about m to the 7th over m to the 2nd? M to the 5th. Top or bottom, Chelsea? Up top. So you're going to have 1m to the 5th over what here? 1m to the 5th over 3. And if, again, like I said, if you would check answers anywhere, is the book going to write this as 1m to the 5th?
No.
They're just going to put
M to the fifth.
over 3. Okay. All right, I think we've got a pretty good handle on this. Prove it to me that if you can handle these two problems, you're going to be in good shape today. So try these. I'm going to go 6m to the 5th up top here times m divided by 15m to the 3rd. And then this next one, let's go n to the 2nd times 10n to the 6th over 5n to the 3rd. See what you get with those two expressions real quickly. And check with someone when you're done. go ahead and talk here, done or not. Did anybody get an answer for the first one for me? Who's got an answer? Seth, what have you got, kiddo?
2m to the third power over 5.
2m to the third over 5.
Yeah.
Okay, let's just double check here real quickly. Guys, up top, this becomes 6m to the, this is really m to the first right here, so isn't this 6m to the 6th up top? Everybody agree? And at the bottom, our denominator is still 15m to the third. Looks to me like Seth recognized that with these coefficients of 6 and 15. Looks like you recognize that 3 will go equally into both. How many times does 3 go in there? How many times does 3 go into 15? Okay, you're with the 2 and 5 part. What's my 6 minus 3 part going to be? 3. I'm going to keep the m to the third up top since there's more m's up top than there are on the bottom. Very good. Excellent. This next one, this would become on the right 10n to the what up top, guys? What's the 6 and 2 going to add up to? You're getting multiplied up top, right? So it'd be 2 plus 6, wouldn't it? So 10n to the 8th up top, isn't it? Bottom is still 5n to the third. Split. How about the 10 over 5? That divides evenly, doesn't it? What value?
5.
Oh, careful. 10 divided by 5.
Well, 2 over 1.
2. And then 8 minus my 3 would be? So 2n to what power here? Whoops. 2n to the 5th. Very good.